So for part A of this problem, we have the surface of the Earth, and we're shooting a projectile to a distance where it can't go higher. And now we know that from the center of the Earth to that distance is going to be 2 times the radius of the Earth, because we're told that in part A, to a height above the Earth equal to the Earth's radius. So if we use conservation of energy, we get that the kinetic energy plus the potential energy initially has to equal the kinetic energy plus the potential energy at the last point. And we know that at the highest point, the kinetic energy has to be 0, because otherwise it would continue to go on. So we can say that 1/2 mv1 squared, this is what it's released with, the velocity, muzzle velocity. The potential energy is minus g, mass of Earth, mass of object, over. When it's released from the Earth's surface, so there's only a distance of r sub e from the masses. That equals 0 plus a negative g, mass of Earth, mass of system, over. At the highest point, it's twice the radius of the Earth away. So this tells us that 1/2 mv1 squared equals g, mass of Earth, mass of object, over 2 radius of the Earth. And now we can say that the masses cancel out, the 2's will cancel out, and we're left with v1 squared equals square root, g, mass of Earth, over the radius of the Earth. And if we plug these numbers in, we get the square root of g, which is 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. The mass of the Earth, which is 5.98 times 10 to the 24th kilogram, over the radius of the Earth, which is 6.37 times 10 to the 6th meters, which gives us a speed of 7,910 meters per second. By the way, this is about the same as 28,500 kilometers per hour, or 17,700 miles per hour. So, just to give you an approximation of what this looks like. For part B now, we still have the radius of the Earth, but now the thing is going to infinity, so the final distance is unknown. Again, if we use the kinetic energy initially plus potential energy initially has to equal kinetic energy final plus potential energy final. At infinity, right, it's going to run out of fuel, so it's going to not have any kinetic energy And at infinity, if we put infinity in for r, there's not going to be any potential, so these are equal to 0 at the end, which leads us to 1/2 mv1 squared minus g, mass of Earth, mass of object, over r sub e equals 0. And that leads to the velocity 1 equaling the square root of 2g, mass of Earth, over r sub e. And if we plug these numbers in, 2 times g times mass of Earth, 5.98 10 to the 24th kilograms, radius of the Earth. That will give us a speed of 1.12 10 to the 4th meters per second, which is equivalent to 40,200 kilometers per hour.